here I have a pretty interesting geometry question, but I know this is just algebra. So yes, we will actually be using algebra to solve that question. So this is still just algebra. But here's the question, check this out. Suppose we start with a equilateral triangle, meaning that it's a triangle with all the sides and all the angles being the same. And just to be a little more legitimate, I'm just going to put on this notation here. Alright? And because all the sides are the same, I'm just going to label them as x's, like so. Alright, so what's the question? Have you ever thought about if it's possible to have a triangle like this so that its area and its perimeter are equal, ignoring the units? Because I know the units will never be the same. But just look at the numerical value. Let's say the area is 2 and the perimeter also happens to be 2. Just don't look at the units though. But anyway, this right here, the question is we want x so that the area is equal to the perimeter. Alright? And you know the deal, please pause the video and try this first. Done? Alright, cool. Let's see. So this is actually not so bad, but it's actually pretty interesting, I would say. Not only because I came up with this recently, but like, yeah, let's just solve it. Alright, anyway. The reason that this is interesting is because you can put this as a question and ask your students, and then it's like a prank because, okay, you give them this triangle, ask them for the area, and also ask them for the perimeter. They solve them, the answers are the same. Did I do anything wrong? Anyway. Alright, so let's see how we can find the area of an equilateral triangle like so. The way that we can do this is that we can just make a vertical cut, right? So that way we can have two equal pieces of triangle because we need to have the height. And in that case, this part is just going to be 1/2 x. And this right here, we don't know what it is. I'm just going to call that to be b. Actually, no, let's call that to be h. Why? The height, yeah? Alright, so now if we look at this red triangle, we can use the Pythagorean theorem to help us out. So here, I'm just going to write it as this square, 1/2 x squared, and then we add it with the h squared, and we have to make this equal to the x squared. Let me put it in red. Yeah. And our goal is to figure out h. So let's move this to the other side. So this is h squared equals, this is x squared minus this, and work that out. 1/2 squared is 1/4, and then we have the x squared. And then right here we can get a common denominator, which is 4/4. So h squared equals 3/4 x squared, and then we can just take the positive square root because h has to be positive. We are just talking about a real triangle. Anyway, h equals square root of 3, and then square root of 4 is just 2, and then square root of x squared is just x because just the positive x, right? So with that being said, we know h is that, so that means the area will be what? 1/2 base times height. The base is all this, which is just that x, and then the height is that h, which is that. So I will just put down square root of 3/2x. So this right here is the area. Yeah. And then how about the perimeter? Well, perimeter is actually just, we add these 3 x's together, so it just gets 3x. So that's very straightforward. Cool. So now we can just solve for x. Multiply this out, we will get square root of 3 on the top, and then 4 on the bottom, and then x squared on the side. And then right here, this is going to be just 3x. And technically, you can divide both sides by x because x should not be equal to 0, but that's actually a bad habit, so let's not do that. But because we're talking about geometry, so x should not be equal to 0. Otherwise, you don't have a triangle. But anyway, let me move this to the other side. So we are going to get square root of 3/4 x squared minus 3x. That's equal to 0. And then I will factor on x. And then we will get square root of 3/4 x to the first power minus 3. And that's equal to 0. So here we can say, x is equal to 0, but this is not acceptable in a geometry situation. So we're just looking at this square root of 3 over 4x equals 3, right? Because this has to be equal to 3 in order for the whole thing to be 0. And then just work this out. And to do so, we can multiply the top and bottom by 4. Well, actually multiply the reciprocal here. 4 over square root of 3, and then multiply this by 4 over square root of 3. Cancel, 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 cancel. X equals, okay, 3 over square root of 3. Just that part. I will tell you this is equal to square root of 3 because we can do this. Right? Rationalize the denominator. On the bottom we get 3. Wrong color. On the bottom we get 3. And then on the top we still have this 3 and then this square root of 3. So you can see that they cancel. It's just square root of 3. So this is just square root of 3. But we have 4. So it's 4 square root of 3. And this right here will be the x value. Okay, so here we have it. If we have an equilateral triangle with all the sides being 4 square root of 3, guess what? You can now ask your students or your friends, please compute the area and also please compute the perimeter. They should freak out. Wow, the answers are the same numerically without the units. But yeah,